Chapter 6, Section 5, Linear Inequalities, Part 2. When a linear inequality is in slope-intercept form, it is easy to graph the line and determine which direction to shade. That's what we talked about in the last lesson. However, when a linear inequality is not in slope-intercept form, we must first solve for the inequality for y, or we can graph the line in standard form and test a point to determine which direction to shade. So if you remember back to graphing lines, talking about standard form, you can use that, or you can use inverse operations to get y by itself. This first example, we have 3x minus 2y is less than 10. We know that's a linear inequality. It has an x, it has a y, and it has an inequality symbol. However, in this case, this is not going to be just as quick and easy as it was yesterday because it's not in slope-intercept form. So I have to go ahead and solve for y. To solve for y, my first step needs to be subtracting 3x from both sides, which leaves me with a negative 2y is less than negative 3x plus 10. The reason why I would write it as negative 3x plus 10 is because slope-intercept form, if you remember, is mx plus b. So I want my x with its coefficient to come first before the 10. Now y is still not by itself. I still am multiplying by a negative 2 here. I need to use inverse operations again, which means that I need to divide by a negative 2 on both sides. If you remember back to when we were talking about just solving an inequality, if we multiply or divide both sides of an inequality by a negative, we have to flip the inequality sign. Because I am dividing both sides of this by a negative 2, I need to flip my inequality sign, which means it becomes y is greater than a positive 3 over 2, because a negative divided by a negative is a positive. So a positive 3 over 2x, and then minus 5, because a positive 10 divided by negative 2 is a negative 5. Now I can graph it just like I graphed them yesterday. So I would have my y-intercept at negative 5, count my slope, rise over run, so go up 3 to the right 2. Do it again if you have enough space. This line is going to need to be a dashed line because it's just greater than, it's not greater than or equal to. I also know that I need to shade above. If you look at the final inequality that I solved for y, we know that y is greater than, so we need to shade above the line. The next example, we have x minus y is greater than 2. Again, this is not in slope-intercept form, but I can write it in slope-intercept form fairly easily. The first thing I need to do is subtract x from both sides, which would give me negative y is greater than negative x plus 2. I cannot solve for a negative y. I need to have a positive y before I can say it's in slope-intercept form. So to get rid of my negative y, I'm choosing to divide by negative 1. You could also multiply both sides by negative 1. It's going to do the same thing. All dividing by a negative 1 does is change the signs or make them the opposite. It is also going to flip my inequality sign. So a negative y divided by a negative 1 is a positive y. We need to flip it so we have y is less than a positive x minus 2. Again, I'm going to have a dashed line because it's just less than. My y-intercept is at negative 2. My slope is going to be 1, so I have a dashed line right there. And then it's y is less than that number, or that line, so we need to shade below. Next, we have this equation, or inequality. It's x plus 2y is greater than or equal to 5. I'm going to go ahead and show you, just really quickly, the way that you could use standard form for this. To graph in standard form, we have to find the x-intercept and the y-intercept. To find the x-intercept, we plug in 0 for y and solve for x, which would be 5. To find the y-intercept, we plug in 0 for x and solve for y, which would give me 5 divided by 2, which is 2.5. We know this line needs to be a solid line. We know the x-intercept needs to be 5, the y-intercept needs to be 2.5. So that would be my first line. Now I need to decide where to shade. If I'm using this, I'm going to go ahead and check the point 0, 0, just like I did yesterday, because that is not a point on the line, and 0, 0 is going to be a really easy point to check. When you plug it in, you get 0 plus 2 times 0 is greater than 5. Well, 2 times 0 is 0. 0 plus 0 is just 0. This is not a true statement. 0 is not greater than or equal to 5. So I need to shade the on the side opposite of where 0, 0 is. So I need to shade above. This next example says, suppose you can spend no more than $20 for hot dogs and hamburgers for a picnic. Hot dogs cost $5 per package and hamburgers cost $8 per package. What are 3 possible combinations of packages of hamburgers and hot dogs that you could buy? Something that I want to clarify really quickly right off the bat is that if you go into a grocery store, they are not going to let you buy half a package of hot dogs. You have to either buy the whole package or no package at all. So, just wanted to throw that out there before we start answering this question. I have enough information to write a linear inequality here. I know that I can spend no more than $20, so whatever I spend has to be less than or equal to 20. I'm going to go ahead and say that X is going to be hamburgers and Y is going to be hot dogs. So when I write my inequality, if X is hamburgers and Y is hot dogs, I would have 8X plus 5Y has to be less than or equal to 20. I get the 8 times X because it's $8 per package of hamburgers, 5 times Y because it's $5 for every package of hot dogs, and then I know that I can spend no more than $20, so it has to be less than or equal to 20. Go ahead and solve for Y by subtracting 8X from both sides, and then we need to divide by 5. My inequality is not going to flip here because I'm dividing by a positive 5 on both sides. And it simplifies to Y is less than or equal to negative 8 over 5X plus 4. Go ahead and graph the line. Every point on this line is going to be included because it's less than or equal to. And then I'm going to shade below the line. Now, if we look at this, we already said that we could not buy like a half a package of hot dogs. You either have to buy the whole package or no package at all. There's something else about this graph that wouldn't quite make sense. Can you buy a negative number of hot dogs or hamburgers? The answer to that would be no. You have to, if you're buying hamburgers or hot dogs, it's going to be a positive number. So all of the area that I just took out in black says these cannot be solutions because you can not buy a negative number of hot dogs and hamburgers. The question asked me, what are 3 possible combinations of packages of hamburgers and hot dogs that you could buy? They only asked for 3, but I'm just going to go ahead and show you all of the combinations. You could buy 0 packages of hamburgers and 0 packages of hot dogs. Your picnic might not be very filling, but you would have spent less than $20 on hamburgers and hot dogs. You could buy 1 package of hamburgers and no hot dogs, or you could buy 2 packages of hamburgers and no hot dogs. You could also buy 1 of each. You could buy 1 hamburger and 2 hot dogs. You could buy 0 hamburgers and 1 hot dog, 0 hamburgers and 2 hot dogs, 0 hamburgers and 3 hot dogs, or 0 hamburgers and 4 hot dogs. Where I got all of those combinations would be the whole number ordered pairs in that graph, either the yellow part or on that red line. And it is important to go ahead and make yourself that note that X is hamburgers and Y is hot dogs so that you know which is which when you're looking at the graph. This next example says, which inequality represents the graph below? We have this graph. If you just look at the graph, we can tell that we have a solid line, and we can also tell that it's been shaded below. I can immediately eliminate 2 of my choices because I have a solid line. Because I have a solid line, it cannot be B or C. I know that it has to be either greater than or equal to or less than or equal to because of the solid line in the graph. The next thing that I need to look at is if you look at A and D, they both are the exact same inequality with the exception of Y is greater than or equal to, and D, Y is less than or equal to. If we look at the direction that it's shaded, we know that the answer would have to be D, which is y is less than or equal to 1/2 x plus 3, because the shading is below. Today's assignment is on page 422. It's numbers 1 through 14.